Okay, and we're back. Okay, so in this is an arithmetic sequence. So let's continue doing this problem with the arithmetic sequence. Find the next number in the sequence, check. Found the fifth sequence, found the fifth number. Write a formula for the nth term. So here's the nth term of an arithmetic sequence. We can write that down. Alright, there it is. So the nth term in this sequence, we start with the first term, which is 3. And then you plug in n. Well, we want n just to be n. We don't want it to be anything. Then you could plug in 1, and the common difference was -4. So there it is. This is the nth term. Now we can make it pretty. Distribute the -4. Hold on. Let me write it there. Distribute the -4, which makes this -4n. Distribute the -4, which makes this +4. And we can continue to write this as -4n plus 7. And look at that. That's a line. That's our old friend mx plus b. Remember that from algebra? Mx plus b. An arithmetic sequence is a line, if you want to think of it that way. So that's the nth term. That would be an equation for the nth term. So if I plug in 1, I get -4 plus 7, which is 3. If I plug in 2, I get -4 plus 7, which is -1. If I plug in 3, I get -12 plus 7, which is -5. If I plug in 4, I get -12 plus -16. Sorry. What am I at? If I plug in 4, I get -16 plus 7, which is -9. And so forth and so on. So this is the nth term. This will get you any term of the sequence. Okay, last thing we got to do is we have to find the sum of 10 terms of this sequence. Now you could just write out the 10 terms and add them up in your calculator. But what if you have to do like the sum of 50 terms? So the sum of n terms of an arithmetic sequence is right here. And I'm going to write it all out and then plug in. So we don't know what the 10th term is, so I have to use this equation. This is if we knew what the 10th term was. Now you can use this equation to find the 10th term, -4 times 10 plus 7. But let's just say we don't know what it is. You can use this equation. We're going to do n divided by 2, 2e1 plus n minus 1 times d. Alright, so if we want 10, that means that n is now 10. We're going to do 10 divided by 2. 2 times the first term, which was 3, plus n, which is 10, times the common difference, which was -4. Okay, so lots of parentheses going on here. Work within the parentheses. We can call that 5. We can call this 6. We can call this 9 and times -4. So this is 5 times 6 minus 36. So 6 minus 36 times 5. This would be a -150. So if I add up 10 of these, it's going to add up to -150. All right. So that's actually the lesson. That's like an introduction to sequences and series. In general, it's all about these formulas. Step 1 is you got to decide, are you arithmetic or are you geometric? And then a lot of people get these wrong. This is for the sum of your sequences, and this is for the nth term. All right, do the rest of the back worksheet. Here's an interesting article. Is there really a true answer to a math problem? All right. So, according to this formula, according to our intuition here, the next term here is 1536. The next term here is negative 13. But go read this article. This article is claiming that it could be any number. You could find an equation such that the next number is any number possible. So is there actually an answer to these questions? Interesting. Okay. On the back is your homework. You have to do the rest of these problems. And then you also have the solutions to the problems as well. Now these would be paper 1 problems. Yeah, all of these are paper 1. Paper 2 problems are a lot longer. So what we're going to do is, for the rest of the video here, we're going to go through some of these problems together, and the rest are yours for homework. We'll just do number 1 to get us started. It's a good little intro problem. The first 4 terms of an arithmetic sequence are shown. So arithmetic, make sure you're on the arithmetic row in your formula packet. Write down the nth term for the sequence. Well, the nth term is that. So now you just have to plug in to this. The nth term is the first term plus n. We keep n when we're doing the nth term. You just keep n as n. And then you write down the common difference. So in this case, 1 plus 4 plus 4 plus 4, 4 again. There it is. That's all you have to write. You don't have to be fancy. That is the nth term equation for this sequence. We can check it. If I plug in 4, I should get 13, because that's the 4th term. So 4 minus 1 is 3. 3 times 4 is 12. 12 plus 1 is 13. Okay, next, calculate the 100th term of the sequence. Now you could just write it all out until you get to the 100th term. Or we could plug in, we could use this equation now. I always write my u's as mu's. And that will find the 100th term of the sequence. So let's just work this out. 100 minus 1 is 99. 99 times 4 is 396, plus 1 is 397. Okay. So that's how we'd write that. That's the 100th term. 100th term of the sequence. C. Find the sum of the first 100 terms of the sequence. The sum of the first 100th term. Now, here's a nice little thing. Do we know the 100th term? Sure do. The 100th term is that. So we can actually use, because we know it, we can use this equation right here. So, sum of 100 terms we can use this equation. We can say the sum of 100 terms is 100 divided by 2, so n is 100. The first term, which is 1, and the 100th term, u sub 100, is 397. Okay, so plug that in your calculator. The sum of 100 is 19900. And we can leave our answer like that, because that is Nicely rounded 3 sig figs already for us. So this is the 100th term. This is the sum of 100 terms. Quite a big difference in these numbers. Alright, let's skip down a couple problems. To number 4. The 4th term of the arithmetic sequence is 12. The 10th term is 42. So here's what this would look like. 1, 2, 3, 4. The 4th term is 12. And 12, 5, 6, 7, 8, 9, 10. Where was I? Got lost. And the 10th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th term is 42. So, pause the video, figure out the rest of number 4. Alright, unpause. Here we go. So this is the 4th term, and this is the 10th term. So given that the first term is U1, which would be U1, and the common difference is D, write down 2 equations involving U1 and D that satisfy this information. So here's our 2 equations. So this here gives us 1 equation. We're going to use this equation. Okay. So according to this information, if I make n 4, so the 4th term, I get out 12. So the 4th term is 12. First term is E1. 4 minus 1 times the common difference. So that's 1 equation. It involves D and U1. And that's what we need. We need D and U1. Make an equation with this information using the same equation. Same equation, just it's a different n. N is now 10, and the 10th term is 42. So the 10th term is 42. We have U1 plus 10 minus 1 times D. So now we got 2 equations like that. And it says solve the equations to find the value of U1 and D. Okay. So that's going to take a little bit of extra paper. So I'm going to go ahead and solve these equations. So the first equation, I'm just going to simplify. That's 3D. Here's my first equation. My second equation, I'm going to simplify. That's 9D. And now I can do a simple system of equations here. What's 12 minus 42? 12 minus 42 is negative 30. What's U1 minus U1? Nothing. It's a system of equations. What's 3 minus 9? Negative 6. D. Divide that over. We get the common difference is 5. Let's check. 12 plus 5, 17. Plus 5, 22. Plus 5, 27. Plus 5, 32. Plus 5, 37. Plus 5, 42. We did it. We got it right. Whoops. That was not in the screen. I was just adding 5. And I got to 42. Now we got to find U1. Okay, so now that we know that D is 5, you can go back up here and plug in 5. So 12 equals U1 plus 15. Subtract 15. Negative 3 equals u1. So this ends up being negative 3. Let's check it. If I add 5, negative 3 plus 5 is 2, plus 5 is 7, plus 5 is 12. Alright, so I did it. I was able to figure out everything. So 4 got a little tricky because it involved some algebra from the past. We had to use 2 equations, and that's what that means. If you are told to write an equation in terms of like u1 and d, that means find 2 equations with u1 and d in it. We use this to make an equation, we use this to make an equation. That was a tough one, which is why I'm going over it with you. Let's see here, we got time for a couple more. Let's try, let's do 8 together. 8's a really hard one too. There we go. So the first 3 terms of the arithmetic sequence are the following. Show that k equals 4. Alright, so this is arithmetic, which means if you take this minus this, it's the same thing as this minus this. And that's what they're going at here. Okay, so if I do, it's like if this is my arithmetic sequence, 2, 4, 6, 8, 10. 10 minus 8, whoops, 10 minus 8 has to be equal to 8 minus 6. Okay, because that's the way arithmetic sequences work. If you take 10 minus 8 is 2, 8 minus 6 is 2, 6 minus 4 is 2, 4 minus 2 is 2. Alright, so that's the idea here, and like I said, this is a tough one too. 10k minus 15 minus 5k minus 2 should be equal to 5k minus 2 minus 2k plus 3. Ran out of room there at the end. Alright, so let's work this all out. Let's get some more room here. 10k minus 15 minus 5k, don't forget to distribute, plus 2 equals 5k minus 2 minus 2k minus 3. Now it's all algebra, so but you will get k equals 4 when you do your algebra. Alright, you can do the algebra on your own. So k is 4. That was the tough one. Next, find the values of the first 3 terms of the sequence. Now even if you couldn't get a here, you can use the problem to get b. So if k is 4, all you do now is plug in 4. 2 times 4 is 8, 8 plus 3 is 11. 5 times 4 is 20, 20 minus 2 is 18. And 10 times 4 is 40, 40 minus 15 is 25. And here you can see our sequence. You can see the common difference is 7. Plus 7 plus 7. And the value of the common difference equals 7. Calculate the 20th term of the sequence. Okay, so we need the 20th term. We're going to use this equation because it's arithmetic. We're going to use this equation. Sorry, n minus 1 times d. So for the 20th term, you plug in the first term, which is 11, 20, and then the common difference is 7. So if I plug that in our calculator, you get 144 for that. So eventually, if you keep going in this sequence, you're going to get to 144. That'll be one of the terms of the sequence. Find the sum of the first